Anyway, you there are container.
Shall we start?
Yes, sir,
Or we are waiting for anyone?
no, you can start.
Yeah, good morning, Docker. So, in the last session, I'll just give an overview. So, until now, we started with what is DevOps, right? Initially, in the first session, we started with what is DevOps, why it came into existence, and then we saw about cloud computing. What is the basis for cloud computing? Why it also came into existence, and then we started with AWS, right? Previous sessions. So we got to know about the basics of AWS, how you create a VPC, EC2 instances, right? Load balancers. We tried hands-on on the application load balancer, auto scaling groups, how to create a virtual network, right? Subnets, VNets. So on the cloud computing side, I believe that so basics are covered. So we are good to we should be at a in a capacity to create infrastructure on the cloud now. So creating networks, creating an EC2 instance, creating a database server, how to configure the load balancers and everything. So on the cloud side, I think we are good. So if you guys have any doubts, right, um, we can cover that up as well from the previous session, right? Otherwise, we'll go ahead with the Docker. Um, so yeah, on the cloud side, I believe we are done, right? And we'll come back to cloud when we are doing application deployments as well. Okay. So the next step, what we need to know in the DevOps side of things is Docker. So Docker is very basic, right? For any DevOps engineer or even a developer at this point of time. So knowledge of Docker is an added advantage, right? So everything is now, we don't have a traditional older style applications where you would have lines of code, you deploy it in a traditional method. So now any application in the current in the uh, um, recent scheme of things, we are everything is containerized, right? So any application you take, it is you have to dockerize the application, whichever project you work on. So Docker is very important, right? So any project you work on, you would have to know Docker skills. So that's why we'll try to cover up the fundamentals of Docker in this session. We'll try to see how to run some basic commands around Docker. How do you run images, right? Containers. How you set up volumes, networks in Docker, and how you create a Docker file with all the commands that are needed. How do you create a Docker compose files, right? So I have an agenda page as well, right? So in the agenda, so we'll try to cover up the basics. So if I start directly with writing a Docker file, so it will not make much sense. So you should know why you're writing it. So what is the background of it, right? So we'll try to cover that up, right? What is a container? What is
This conference will now be recorded.
Yeah, what is a container, and what are the differences between a Docker virtual machine, right? And basic concepts around Docker, okay, and containers and images. What is the difference? And we'll try to do some hands-on using trying out some basic Docker commands, right? And I have some other slides as well where we'll see how we forward the ports, how you set up volumes and everything, right? So we'll go with basics. We'll not jump directly into writing a Docker file, right? We need to cover up the basics first. So how it works, the architecture behind it, and then we'll go into creating a Docker file, right? Spinning up our own application. We'll take a sample application. It could be an Node.js or a Python application. We'll try to write a Docker file for that. Okay. So let's get started, right? So any doubts on the agenda or anything in particular, right? Any on any slide or any time you're not getting the concept, just stop me there. It's not that at the end of the session you have to ask. You might forget by the time. So then and there, try to clear the doubts, right? Whatever you have. There's no harm in stopping. You just you stop me there and you clear your doubts. Okay. So let's get started with this, right? So, so the main, when you talk about Docker, the first thing first keyword that comes into mind is container. Okay. So in general terms, what is a container? You might have heard the word container outside of Docker, right? Say shipping container or a truck. In a truck, you have containers, right? So it is the word is taken from the same concept, right? Container is like a package, right? It's like a box where you store all the required things, right? In case of a shipping container, you ship multiple uh, things, multiple like packages inside that container, right? So it's similar concept, right? You take that analogy so that you remember it easily. So I try to do that. You keep an analogy, right? Then only you'll remember it for a long time. So container, you take a reference from a shipping container, right? So what it has. So it's similar concept in Docker. So a container is a way to package applications, right? So for example, your application. So let's take, for example, a database container. Okay. So you need to work on a Postgres database. So you can spin up a Postgres container. So you need not you need not do all the dependencies. So in a Postgres container, you need to set up some dependencies, some libraries. You need all that, right? You need not do that. So you if you take a Postgres container, all the dependencies are included in that container, right? And one other advantage of having a container is it can be shipped easily, right? It is very portable. For example, I develop a container of my own applications. I have an application called App One. Okay, my application name is App One. So if I want to give that application to you, right, I can just create a image out of it, right? I can ship that container, my application container, to you. So when you run that container, you have you can actually view what I have developed, right? So it is actually very portable. So you can basically ship the container to multiple like it is easy to ship the container, right? And the technology is very efficient. The Docker concept, the Docker technology is actually very efficient. It doesn't consume a lot of resources or CPU. It is very lightweight in terms of size, right? In terms of size, in terms of speed and everything. The Docker, the container concept is very efficient, right? Um, so what I'm trying to say is, the container. So basic, when you hear the word container, you should remember the packaging of all the application dependencies, all the required prerequisite softwares, right? So that is a container, and it's easily portable. It is you can transport, you can ship it to multiple. Am I audible now?
Yeah.
Yes, sir.
Okay, sorry. I don't know when it got dropped. Let's start again, right? Okay, we were talking about containers, right? I think that's when we got dropped. So, like the container, the basic concept, like I was saying, it is way to package an application, right? And all the dependencies associated with it. Any doubts in container? You have anything? So, what you didn't understand what a container is? Let me know, right? Okay. So, so this is what I was talking about, right? So there are in software development life cycle there are two steps, right? Two major steps. So one is a development phase, one is a deployment phase, right? So how application development used to happen before before containers came into picture, and now with containers, with use of containers, right? So for example, if you take look at this diagram, right? So for example, we have two different developers trying to develop some application, trying to work on some project. Okay, so they require a Postgres SQL server. They need to have a Postgres SQL server. They need to have a Redis cache. Okay, in their machine to integrate it with your application, right? So what each developer, so let's say one developer is using Windows, right? Consider this as Windows. Consider another developer using Linux, Ubuntu machine, right? So for example, in a Windows machine, if I try to install Postgres server, the steps are different, right? So in Postgres, you need to go to the Postgres website, look for an exe file or a zip file. You download that into your Windows machine, execute it, right? You execute it, run next, configure the paths and everything. Then it gets installed. So in Windows, that is a process. Similarly, in Linux, you have to run certain commands. The app get install Postgres, right? You need to modify some paths and everything. So the process is entirely different based on which operating system you use, right? So for example, while installing Postgres, for a Windows developer, when he's installing Postgres, he missed some step, or he changed some environment variable mistakenly, right? So whatever application he has written, the environment variable is not matching, so the application might not work, right? So there are many manual mistakes possible, because for each environment, for each operating system that you work on, the steps involved are different. For Windows, it is different. For Linux, it is different. And for different flavors of Linux, it might be different, right? For Ubuntu, for CentOS, for RHEL, the steps could be different, right? So before the advent of containers, so this is how we used to actually install all the required dependencies for our application. For example, for Postgres, for Redis, right? This is in case of a local development, or in case of a server deployment, right? We used to follow the steps of manually installing the softwares, manually installing the dependencies. But now with the invent of containers, so be it on any machine, right? Be it on Windows, be it on Linux, be it on like Mac, or any different operating system that you're using, all you need to do is find that exact same container, right? You look for a Postgres container inside the Docker Hub, you download that container, so it would run exactly the same, be it on Windows, be it on Linux, be it on any other operating system, right? So all the environment variables, all the configurations is similar to your machine, as well as the machine that the other developer is using. So they cannot complain that it is working in my machine, it's not working in your machine. So that is that. So we normally hear a lot of these statements, right, from the developers. It is working in my machine. I don't know why it's not working in your machine. So that used to happen before Docker came into existence, right? So now nobody can say that it's working in mine, it's not working in yours, because we both are using the same container. So there's hardly any chance that will happen, right? So the point I'm trying to make is before containers, it's all manual process, right? There were a lot of dependencies that you need to do it manually, right? Now in case of containers, since the concept of container is packaging, right? The shipping containers. It's packaging the entire dependencies and everything together. So it's all packaged into a single container, and you can just download that container. For example, you need Postgres in this image. It's showing Postgres container. So all you need to do is download that into your machine and start working. Okay. So this is in the development phase. So you need a Postgres for development, right? So in the development concept, this is in development context. This is how containers are helping us, right? In case of deployment, okay. So development is what you create an application, a web application, or a software, right? In case of deployment, you're running that application, right? So so in development, at least the Docker was it was helpful, but not to a little extent, right? You can still work around with that. But in case of deployment, it is more. This is where it shines, right? The Docker concept, the container shine, because for example, in case of a traditional application development process, right? For example, take a Java application that you're deploying. So basically, you need to have a certain version of Java, right? For example, developers are using Java 1.8. So the prerequisites for running your application is you need to have a Java version 1.8 required, and you need to run. Say you might be using a build tool, right? You need to use Maven compile or Maven package to generate a jar out of that application, right? Compile your Java source code, right? You generate a jar, and then you run that jar onto the server, okay? And you need to configure the database external dependencies are there, right? You need to configure, you need to set up that what do you call the properties file or DB endpoints in your application, right? You need to set the Spring profile, whatever. So all these are manual steps, right? So first step is if somebody wants to deploy an application onto an AWS EC2 instance, so he just needs to log into that server, log into that virtual machine, install Java inside that, the specific version 1.8 version of Java. He needs to run. You need to install Maven, right? You need to run that application Maven. You need to run certain commands called Maven compile or Maven package, and then he generates a jar. Then from that jar, he'll try to run Java jar, give the Spring profile, give the DB, update the DB extensions and everything. Then his application will start running. So these are all the manual steps that needs to be done if we are not going with Docker. Okay. So normally what happens is prior to DevOps or prior to Docker, right? So this all would be documented. So the developer team, right, would prepare a MOP, method of procedure document, where this specifies step 1, download Java 1.8, step 2, run this, go to this path, step 3, modify this this XML file, right, modify this particular this application properties file, update this string to the database URL, and then run this command Java jar install Maven. So there will be a 2-3 pager document that the operations team, right, needs to follow to actually deploy this application. So this is actually a very, very tedious job, right? So you think of it. So if somebody wants to, you develop a Java application or a Python application, so you give a document to the team listing out all the steps, right? So the other person needs to execute those steps. So that is actually a pain, right? So that is how it used to be done prior to containers, right? Any doubts here, guys? Okay, so what I'm saying is, so even in the text that is written here, right? So there is a lot of configuration on the server needed. Configuration as in the version of Java, right? And dependencies and everything, right? You need to have Maven or Ant, a build tool, or any other dependencies for that matter. And you need to have a textual guide for deployment. This is nothing but a document. One second. So there is nothing but a document, right? So document detailing the steps that are required, and there would be some steps if the developer has missed, then the whole application would like fail, right? So that is how it used to happen before containers, right? So with containers concept, like a container is what? It is a way of packaging everything together, right? So what happens in the current scenario, even in the project that I'm working on currently, right? So we have developers, right? Developers and the operations team, we work together, right? So in our case, it is just the DevOps engineer who actually creates a Docker file for the application. So what Docker file or Docker file contains is what all the document, what all steps you had, right, to install Java, to modify that file, copy this folder, right, expose these ports, all that you had, right? So all that is actually written as configuration, right, inside a container, right? And you package everything what all you needed. So if you see this blue box, right, you have the configurations, as in which file to modify, which file to copy, all that. You have that jar, right, how to execute, which command to execute to generate a jar, and what all the dependencies, the external dependencies, the databases, the Redis cache, and everything. You package everything into one particular piece, right? You generate a Docker image, you give that to the operations team, okay? Or normally you don't give it directly, you store it in a ACR, you store it in a Docker hub or a container registry, and that's it, right? You have you have your application in a file, right? You give it to them. All the operations team or whoever is running that, the DevOps engineer needs to do is just run that Docker image, then your application would actually be running. So there is very minimal chance of failure, then very minimal effort on to both the sides, right? Even for the developer it is easy, right? Even for the operations team it is easy. So they package it, everything, give it to them. These guys just download that package and run that, right? So when you compare it with the previous step, so it was very tiresome, right? Now it has become very easy, right? It is all packaged into a single thing. You just have to package it, and the other guy has to just run it. Okay. Any doubts here, right? So guys, so this is most. So you need to understand, right? Why we are actually going with the containers. What problem it solves. So that's what I'm trying to say. Okay. If any doubts here, just let me know even later, right? So we'll move ahead with the next one, right? So before going to how that Docker engine, right, Docker works. So this is how a basic application or a basic operating system would look like, right? So any operating system, Windows, Linux, right, Mac, anything. So you have this. So I'll tell you why I'm going at this level, right? So you might be aware of this, right? Anyways, any computer engineer would be aware. So you have three layers in an operating system. One is the hardware layer, one is the kernel layer, right? And one is the application layer. Okay. So in the hardware layer, you have all the hardware related stack, right? You have the CPU, right? The processors, the memory, the SSDs or HDDs. You have other external devices, right? Storage devices or some other input-output devices, right? So this is all in the hardware layer. In the kernel layer is basically all your actual operating system binaries and packages are stored, right? So this is what communicates with your hardware. Okay, in application layer is where you are running. So you install softwares, right? So this is your application layer. So you install Java or you install DBs, you install the VLC player, anything you install, right? So this is on the application layer. So these are the three. So this is actually a basic architecture, right, of any operating system, be it Linux or OS, Linux or Windows. So in case of, say, for example, Linux OS, you have multiple flavors, right? Like Ubuntu, you have Debian, CentOS, all that. So the main in case of Linux, the kernel is actually same, right? Only the applications on top is different, because Ubuntu you have the proper UI, right? So in case of, for example, Ubuntu, you have the same kernel of Linux and you have an Ubuntu application running on top. Similarly, in case of CentOS, you have the same kernel, Linux kernel, you have an CentOS application running on top, right? So this is how a basic operating system. Yeah, for Windows you would have a Windows kernel, right? So Windows kernel is a different one. So in case of Linux, I'm trying to say you have multiple flavors of Linux. In case of Windows, if you're talking about Windows 7 is there, Windows 10 is there, right? Windows XP is there. So for each, so the kernel would be according to that flavor of operating system, right? See, why I went to that level is we need to know where our Docker actually sits, right? Where our Docker engine actually sits. So this is the three layers that we talked about, right? Hardware, the kernel, and the application, right? So if we compare a Docker with a virtual machine, I believe everybody would be aware, right? So a virtual machine, for example, you have an Oracle VirtualBox software or a VMware in your machine. So you can actually install Ubuntu on your machine, right? So most of us might have done that for our development or for testing purpose. You are running a Windows machine and you want to use an Ubuntu, right? Or you want to use some other OS. So you install VirtualBox in your machine and you download an ISO image for Ubuntu and you try to run it, right? So what happens there is, whatever VirtualBox or whatever VMware you download, that is actually called a hypervisor, right? Hypervisor is actually an emulator of kind, which is actually helping you to run different operating systems on top. Okay, so in case of virtual machines, I'm trying to say what is the difference between a virtual machine and a container. Okay, so in case of virtual machine, you have the same hardware layer where you have your CPU and everything, and you have the same kernel layer where you are having a Linux kernel or a Windows kernel, and the third layer is actually a hypervisor in case of a virtual machine. And in containers, we have something called a Docker engine. Docker engine is similar to a hypervisor, right? Similar to a hypervisor in context where in hypervisor you can have, if you see, you compare these two diagrams, right? On a hypervisor you can have operating system installed. So in case of, if I have VirtualBox installed, I can install Ubuntu, I can install CentOS, I can install RHEL, right? Three different operating systems I can install. So this green, these three different colors, right? But in case of Docker engine actually runs on top of an operating system, right? And you don't need to install the entire operating system. You only need to install the libraries or the dependencies, and then you install the app. So for this purpose, Docker engine need not boot the entire OS, right? So it is very faster in terms of speed, right? So if you want to install an Ubuntu on a Docker versus an Ubuntu on an VirtualBox, the VirtualBox might take 10 to 15 minutes to install Ubuntu. Docker engine would take 10 to 15 seconds to install the same, because it doesn't load the entire operating system. It loads only libraries, right? So this is main advantage in terms of Docker, right? That is why Docker is very faster. It doesn't load the entire operating system. It just loads the libraries and the binaries that are required for that software. But in case of a virtual machine, it needs to load the entire Ubuntu operating system and then the libraries and the binaries, right? You compare these two diagrams, it will be clear for you guys. Right? Any doubts here, guys?
In the case of containers, container engine itself, it has that whatever 3 different OSs, like whatever we choose.
Yeah, container. For example, if your Docker engine is actually running on an operating system, right? So, for example, I'm running Docker engine on Windows, right? So it will take a Windows operating system as a base, and it will try to run it. Right? If you're running the Docker engine on Linux, it will take Linux operating system as base, and it will try to run it. But Docker mainly requires Linux. Linux base actually. So even if you're running it on Windows, it would actually run it on a hypervisor on Linux. Okay, in case of Windows, let me show you that.
Like you are saying, for Docker, the Linux is preferable.
Docker Linux is preferable, but if you're running it on Windows, right, it will still try to create a Windows subsystem for Linux. You might have heard that WSL. So there is a Windows subsystem for Linux software running on Windows. So it will try to use that in our Windows machine to run Docker. See, this is what actually runs on any Windows 10 or 11 latest generation of Windows, right? So you have some software called Windows subsystem for Linux. So for any Docker container, Docker engine to work, it requires Linux. If you are running it on Ubuntu, it would directly run, right? But in case of Windows, it would actually take.
It needs this subsystem of Windows.
Yeah, this is actually like a software, right? It is like a software that Windows. So it comes packaged with Docker only. When you install Docker on Windows, right? So to install Docker, so if you click on this, right, it will download. Try to search this. Install Docker desktop on Windows, right? So actually, it will come with, if you read through it, it will come with this WSL backend, Windows subsystem for Linux backend. Yeah, right. So this comes as part of the executable for Windows.
Windows Docker.
So because of that, you are able to run any operating system on top of Docker. If you compare it here, right? But yeah, that's why you are able to run any operating system on top. Okay. Okay. That was a nice doubt. Any other doubt, guys?
Nice doubt on Babu Attisava.
Okay. Since we are here, right? I'll tell you how we can download Docker onto Windows, or if you're using Ubuntu, right? So it's all available, right? You just Google it out. It's just searching that, right? Searching that on Google, and you come to this Docker website, and you search the operating system that you want, Docker desktop for Windows, right? You just download that executable. Once you download, you have something. Once you run that, right? So this is how it looks, the Docker software. Right. So this is how, once you run this is how the Docker software looks like. So on the left you have the containers that are running. Currently there is nothing running. The images that you have, the volumes, the environments. Okay. So you can actually control it from here. On the notification, you can see a symbol for Docker here, right? If you see, a small notification would be running. So this is dashboard, how you can stop, restart Docker, quit Docker. So this is in case of Windows. In case of Ubuntu or Linux, you just have to run some commands. You can also see that, right?
నాకే అర్థం కాలే.
So you just have to run certain commands. Okay, so like this. So these commands they are given, right? Apt-get update. So it needs to install some prerequisite softwares. So this is all basic. Like you can find it on the internet. So this is the main command. Docker CE. Okay, Docker CE, Docker CLI, and this is containerd. So these commands, if you run, you will have this installed in your Ubuntu machine, right? So it is straightforward in case of Ubuntu. Even in the latest version, Windows 10 Docker, it is straightforward. You just have to select the WSL and install it. Okay. Now coming back to our this one. Okay. So when we talk about this, right, to continue the same topic. Okay. To just continue the same topic. So in case of, we will try to find a difference between a virtual machine and a container. Virtual machine we might have worked on, right, earlier. Virtual machine is known to us. So container is something which we are seeing it currently. So how you compare with this older generation virtual machine versus container? So like I said, virtual machine is heavyweight, container is lightweight. Why? Because virtual machine has on operating system layer, right? You see this, right? It has an entire operating system layer on top, so it is very heavyweight. And Ubuntu ISO would be say 2 GB, 3 GB, right? One operating system image of VM. But in case of Docker, it will be in MBs, right? It will be 50 MB, 100 MB, like that, right? Same Ubuntu image. So it is very lightweight. And the performance is limited. So virtual machine's performance is based on how much capacity you give it to that virtual machine, right? So if you are while configuring the virtual box, you give 2 GB, 3 GB, how much ever you give it to that virtual box. So based on how much capacity you give, it would run. But container, it runs based on it takes the application how much ever it requires, right? So it takes the maximum efficient performance, right?
Like native performance in the sense, what it means? I didn't get it. Native means
So
what it
native means how much ever, like it is just a lightweight application, right? So in case of, say, let's take an example of an Ubuntu operating system. So in Ubuntu, if you're running it on a virtual box, okay, so while spinning up the virtual box, you would give some size to that virtual box, right?
Yes. Memory, like.
Yeah, you would give some memory, how much that image should take. So based on how much you give, that much it would actually run under that particular memory. But in case of container, for Docker, you would specify certain memory. Okay, memory requirement. Let me show you that. So all it is saying is you need not worry about performance. How much ever the image requires, that much performance it is able to deliver, right? Without any lag.
It is not limited to some up to some extent.
Up to some extent, yeah. So how much ever the image or the container requires, so the native as in the original, how much is required, that much performance can be expected, right? But in here, it is limited to how much ever you're configured for the particular virtual box, right? Getting my point? So in case of limited performance means how much ever you have configured for the virtual box, that much storage, that much capacity will be taken. In case of container, how much ever is required by that container, so that much of performance can be expected, right? And in case of virtual machine, it runs on its own OS, like we saw previously, and containers, it runs on the host OS. This point is clear.
Yeah.
And virtualization is hardware level. If you see here, go back to this. So virtualization is happening at the hardware level, right? Because at hardware you are trying to split the resources, right? And in here it is at OS level because it is running on operating system. So at OS level you are doing the virtualization. Here it is running on an operating system. And startup time, it takes minutes, right? If you spin up Ubuntu or some other application, it would take a couple of minutes to run. It takes a lot of time based on your local like laptop's capacity. In container, it happens in seconds, milliseconds it's mentioned, but yeah, it takes seconds. And it allocates required memory. So for example, when you're downloading an Ubuntu ISO, it will tell that it requires minimum 1 GB or minimum 2 GB, right? But in case of container, it requires very less memory space because the image itself will be in MB, so it doesn't require that much of capacity, right? And in case of virtual machine, it is isolated. Yeah, this is one advantages, right? Advantages of VM is it is isolated, right? Each operating system is, so you cannot there is no security risk between these app 1, app 2, app 3, because these three are running on uh, entirely different operating system, entirely different stack. But in case of Docker, it is running on the same OS, so there is so security wise it is less secure, but that doesn't matter, right? But because as long as you're achieving the efficiency, it doesn't matter. So that's why Docker is very popular, right? Because of its speed. But security wise, we can actually configure security using networking. So we'll come to that in a later concept. You can have a certain network network around each of the container, right? So you can have a network here, network here, network here, so that each application doesn't talk to one another, and to make it more secure, right? So that option is also there. So this is one disadvantage, but there are workaround for this. That's what I'm trying to say. Okay. Then coming to the Docker architecture. So this is a basic one, right? What, for example, this is a client machine. Okay, client machine as in I install the Docker on my Windows machine or on a Ubuntu machine. So I have a Docker client also installed. Client as in it's just a interface to connect to that Docker machine. So in my case, client is a CMD or a PowerShell or a Bash, right? Any client. So using that client, you try to enter the commands, right? You try to do a Docker build, Docker pull, Docker run. We'll come to these commands later. But the point is there will be a client through which you try to interact with the Docker engine. Okay, inside the Docker engine you have like Docker daemon. Okay, this is Docker daemon is actually a process running inside the Docker host. In case of ours, it is Docker desktop for Windows, right? Inside the Docker host, there will be a process that is running. So that actually controls different. So we'll not go into detail, right? We'll just see the overview. Okay. So inside the Docker host, we have containers, we have images. Okay. Like I tried to show you here, right? We have we can see the images. I have some image here. I have containers. One container is in stopped state, right? So you have this containers images inside your Docker desktop, and there is a registry. So this is external, right? This registry will come to it now. So this registry is where all your images would actually be stored. Okay, so there are multiple registries. Okay, the official one is called Docker Hub. Okay, let me show you that. So if you go to hub.docker.com, okay, so this is actually a registry. To sign in, one sec. Okay. And keep on explore. Yeah, doesn't require. Okay, man. So see, this is actually a place where all the images are stored. Okay. So this registry part you see, right? So there are multiple registries. So this one we saw here is called Docker Hub. So this is the official registry of Docker Hub, and each there are multiple other registries as well. In case of AWS registry is called AWS Container Registry. Okay. So there is AWS Container Registry. Okay, AWS ECR. It is called, and in case of Azure also there is Azure Container Registry. Okay, you see there is Azure Container Registry. Okay, so there are multiple registries. So registry, the only purpose of a Docker registry is to store Docker images, right? So let's check out this official one. So if you come to this Docker registry hub.docker.com, okay. So each each company has its own official images as well. So if you see on the left, you have official images, right? You click on official images, you see Ubuntu has an official image here running. Okay, so this is provided by the Ubuntu development team only. So there is Postgres, there is Alpine, Redis. So all major software providers have their official images stored in Docker Hub. We can actually go ahead and, so for example, in my earlier example, we were saying we need Postgres, right? So you can actually come here and download this official image, or you can have, if you don't want official image, you can also download any other images created by anybody else. You can also create one image, push it to Docker Hub for everybody else, right? For example, if I search with Postgres, I clear this filter, right? Search with Postgres. See, if I search with Postgres, right, I see one official image. This is also verified publisher. This is verified from the Docker side, right? So there are some other images as well. Each person would have created one image. So you can also create one customized Postgres image. You push it to Docker Hub for everybody else. You can keep it public. If you keep it public, you can see it here. You can also keep it private so that it is only seen by you or your team, right? So this is where all the images are present. So this registry is where your images are present, and when you do a Docker pull or Docker run, these images are actually downloaded into your Docker host, and it will come to your images section, and when you do a Docker run, it actually starts running as a container inside your Docker engine, right? So we'll see that in an example now. Okay, so let's try to have anything else here. Okay, see, let's try to do this, right? So this is my client, right? So my client, let me open. This is my CMD, right? I have a CMD running. So if I see, once I install Docker, I run Docker -- version, right? It would give the version of Docker I'm running. It is running Docker version 20.0. Okay. So for example, let's go with let me go to Docker Hub. Okay, and I'll search. There is an Nginx web server. You might be aware, right? So let me try to pull this image. Okay, so you click on this, you get some other details around this. Okay, so this is official image, official build of Nginx, and the command to actually pull this image is also given here, docker pull nginx. Okay, and if you come down a little, you see tags. Okay, tags is nothing but different versions of this particular software. Okay, so you have multiple versions. You have 1.2, 1.21, all these versions. So based on your requirement, you can download this, right? And it has details about how to run this. Okay, we'll see this later. For now, what we'll do is we'll try to download this from Docker Hub. Okay, so I just once I have the Docker installed, my Docker is running. If you see here, it is saying it is running, right? And here it is green. So all I have to do is Docker pull nginx. Okay, it's the same command here. Okay, once I hit this, so what is happening is it will try to connect to the Docker Hub, and it will try to download this nginx image from Docker Hub. Okay, so this step is happening. So I did a Docker pull, right? It will come, control will come here. It will try to search if the image is present locally. It is not. It will go to the registry, try to find that image, download it. Okay, see, it is actually downloading it. Okay, so now if you see, it has downloaded successfully. So now if you see under images, it might have stored, right? So if there is a command, these are some basic commands. Okay, so if I give docker image ls, okay, if you see this one, right, docker image, this is the one that we downloaded just now. Tag is latest. Okay, created 8 days ago. Created as in the image was created 8 days ago, and the size is 133 MB. Okay, so we have so once you do this flow is actually getting executed. So I did a docker pull. It it went inside the docker. So docker engine tried to find this under images. It is not present. It went to the registry. It downloaded it, right, and it is present here. Okay, so now again if I try to pull, what happens? Any guesses?
Normally tried some other image basing.
Some other base image? No. Actually, the image version we have given. See, if you see the tag here is actually latest. Okay, so tag is latest as in it will take whichever is. So if you see the latest tag is written here, right? Supported tags 1.2.1. So this is the latest one. So if I'm just doing a pull without giving any tag, it would consider it as latest. You see in the command, using default tag latest if you are not giving any tag. For example, if I want to download say 1.2.0, okay, so I have to give that docker pull nginx colon 1.20. Okay, so now if I am running this, what will happen is it will not. So what happened previously is it actually search for this latest tag nginx. It is already present, so it didn't download it. Like you see, these steps didn't come, right? It actually exited immediately. So if I'm trying to download another version of which is not latest, right? So now again it will download. Let's see this, right? See, it is saying pulling from library nginx. It is trying to download again. So we downloaded this particular tag, latest one. Now we are trying to download this. Okay. So now if I do a docker image ls, now I should see how many entries. 1, 2. It should be 2, right? See, I downloaded the latest one. I downloaded version 1.21. Okay. So now I have 2 images of the same software in my local machine. Okay. So I just did a pull here. Any doubts here? So if I try to download the same thing again, right? It shouldn't download. It should say it's already existing and it should come out. So you can have multiple versions of the same software, same application. Based on the tag, you can download it.
Yeah, bro, you told me like Postgres image we can download instead of software. Can we use it like a Docker image instead of install the software in the Windows or some Linux? In the Windows, for example, we don't need it to install the Postgres server.
We don't need to install the Postgres application. See, for example, if my requirement is I need a Postgres DB, right? So if I want to install Postgres DB on Windows, you have that one big software, right? One exe file that you need to install this, right? So this is how normally you do. If you are coming from a Docker perspective, let's try that since you already asked, right? So this is the official image of Postgres. So if I don't know how big is this. So you can actually download this Postgres image. Okay, in our example, we'll try to run this and we'll try to connect this from PG admin as well. Okay. So like you said, this is possible. Okay. So we can actually download this image, run this container and connect to this DB as well for your local development. Okay. We can actually do that. So that is the answer. Okay. So Postgres, this one image, you can download it and you can run it. So in that case, you need not require this. You can run it as an image.
Yes, bro. If you want to Postgres, we need to download from here and we need to upload in our Docker container.
Yeah, we need to run this container. So for now, I'm just telling about how we download it. Okay, we just saw the pull command, right? So we are just downloading it. How to run it, I'll come in the next lectures. The next topic is that only, how we run that existing containers. Okay. So now I'm just showing you how to download it. So now see, if you see images, we have downloaded these images, right? So first part is download, second part is running it, configuring it, all that will do. Okay. So in the meantime, okay, let's do one thing. I'll download this image. Okay. Let's take a 5-minute break until it gets downloaded. 1 hour, right? I'll keep this for download. Okay. Let's join back at 9:10. Okay. It's 9:06 now. Let this download. I'll connect back at 9:10. Okay. Let's take a 5-minute break. So our Postgres is downloaded. Okay. So now if we try to do an image of LS, we should actually see our Postgres image also present. Okay. See, Postgres image it downloaded. Size is 315 MB. So it downloaded the latest image. Okay. Latest is, if you search for latest, it is 13.3. Okay, 13. If you need some other specific version that you are working on, so for example, in your application you're using 9.6 or something, right? So you can download that. You see here, even in if you're searching in the official Postgres documentation, there is version 13, version 12, all that, right? The tags also would be similar. So whenever they release, any software got released, right? They also release the Docker image for that similarly. So they release it nowadays. They release it for Windows. They release it for Linux. They release it for Docker. So all happens simultaneously. Okay, so whichever version you want, you can install it. Since we have given latest, means we didn't give anything. It has taken the tag as latest. So latest is 13.3, right? This version. So we have downloaded that. Okay, we'll come to how to run that. For now, just remember that we have downloaded this images, how we download images from the Docker Hub. Okay, we'll come back to this, right?
Bro, separate Docker file is there, right? For separate version.
Correct, yeah.
Yeah, okay.
So whichever version you want, for example, now we have downloaded this, right? Similar to how we saw in Nginx, we have downloaded latest, we have downloaded 1.2. So for Postgres also, you can download version 9.7, version 13, version 14, and whichever you want, you can run it as well. Okay. Okay. So this is what we saw, right? We from the client, which is nothing but a CMD, we tried to run our commands onto the Docker host. So it went to the Docker registry, pulled the Nginx image, pulled the Postgres image. It is present here now. So we have not converted this into container yet. We are in this stage. Okay. So let's. So this is before we go into the container, right? So before we spin up the container, let's think of the difference between image and container. So now what we downloaded from Docker Hub, it is called an image, right? Postgres image, Nginx image. So these are all images. And what actually we have that running application, it is called a container. So we'll see what is the difference between image and container. Okay, we need to have the basics clear before moving that. Okay, so image is actually a set of instructions that defines what should run inside container. Okay, so image is actually like we saw in our previous one, right? Application deployment. So like here we said for each for each application to run, it needs to have certain dependencies, this jar, this commands to execute, all that. So all this are actually steps. So each sequence of steps. Okay. So in case of Postgres also, when you download that Postgres image, it is actually having a sequence of steps. So download that, this binaries, that software, internally it would have certain steps. So everything packaged into an image. Okay. So a Docker image specifies which external image to use, commands to run, how to set up file system, and which ports and all needs to be open. Okay. So we'll come to this Docker file. So all these are written as part of Docker file, Docker compose files. We'll come into detail of how to create this. Okay. So image is actually nothing but these are certain steps that are required, okay, to run our container. So containers are actually an executable, right? It's a way to execute the instructions in runtime. Okay. So yeah, I wrote this down so I don't forget. Yeah, Docker image. For example, analogy is recipe. Okay. So for example, image can be considered as a recipe for any dish, right? For a cake, and container is actually the actual cake that you make from that recipe. Okay. From each recipe, you can create multiple cakes. So if you have a recipe for a cake, you can create say a black forest, white forest, multiple flavors of that. So similar, so image is actually a recipe and container is actually the end version of that recipe, right? So that is the difference between image and a container. Any doubts here, guys? So what we downloaded from Docker Hub is actually an image, okay? And what our application final, our end application that will run is called a container, right? Yeah. Okay. Let's get into hands-on, right? So now we have seen a Docker pull. Okay. So now we have we have pulled the images, right? So now straightforward, what I'll do is I'll just run this. First, let's go with Nginx. At the end, we'll come with setting up Postgres, okay? Because you guys asked, so we'll set up Postgres at the end. For now, let's take with the basic Nginx, okay? So I am taking this Nginx. So to run this particular image, I have to do a Docker run. So you can concentrate a little here, right, you guys? So this is what you will be doing. You will be required to do, okay? So once you do a Docker pull nginx, next thing you have to do is you have to run this image. To run plain simple terms, just to do a Docker run and the name of the image. Name of the image is nginx. If I just do a run here, what happens? I'll also open a new tab. Okay. See, it actually started, right? It is actually starting. So if so the main commands is Docker image. All commands we have seen till now is Docker image, Docker pull we have seen. To pull the image, to see the image we saw Docker image. To run that we are seeing Docker run. Sorry. Okay. So in a separate window, what I'm trying to do is there is a command to check which containers are running. Okay. So do a Docker ps. So if you do a Docker ps, you can see which all containers are running. Okay. So if you see our container with ID, this is one generic ID, a unique ID gets created for each container. Okay. Name of the image is nginx. This is a command when it got created 47 seconds ago. It is running from 45 seconds. It is running on port 80, and this name is it auto generates some random names. Okay. So this is auto-generated name. So if you see now our image, nginx image is running on this port, okay, with this container ID. We can also actually try to okay, that's fine. See, so now this image, if you see, it is currently running, right? I did Docker run. It is currently running. So if I want to come out of this, so it is now running in my terminal only. I can't come out of it, right? If I do a Control C on this, stuck, man. Just give me a minute. Why is this stuck, man? Okay, let me kill this then. So I killed the entire page, right? So now it should actually. So it was bound to that session, right? So that's why it was. Oh, it is still running. Okay. So what I'm trying to say is, so now this container is running, right? So we got into this state where this container is running. So now if I want to stop this container, I have to just give Docker stop and the ID of the container. Okay. So I'm just going by very basics. Okay. So first we saw what all commands we saw is first Docker pull, right? Then Docker run to run that complete container, Docker ps to see what containers are running, and Docker stop to actually stop that container. Now once after I have stopped it, I do a Docker ps. Okay, it should not show any entry here, so nothing should be running, right? Nothing is running. So another thing is, if you want to, for example, I am running the same Docker run nginx. Okay, so I don't want to run it on the foreground. I want to run it at detached mode. So the option is -d. Okay, so if I do Docker run -d in detached mode and I give nginx. Okay, so what happens is it will not print the logs here. It will not print anything here. It will just give us the ID and it will exit. Okay, but in the background that will be running. You do docker ps. So this string that you see is actually the ID of the container, right? So in here, if you see, the same one is getting printed here. The first few digits are getting printed. So now if you see, if you want to run it in detached mode, if you do a docker run -d to run it in detached mode. Okay. So
Bro, why it's first time it's taking much time? Like in the second time you run in the detached mode, right? It come so quickly. Is there any?
no, it is the same thing only. See, if I don't run without detached mode, okay. So what will happen without detached mode is it will print all the commands that are happening here only. It will print. See, it is printing it here. It is running actually. It is printing it here. If I open it a new window, the time taken is same only. Nothing difference. Only thing, if you run it in detached mode, you will not see this entry. It is not bound to this this session. Okay, so you can't do anything here. That's why I opened a new tab and I'm trying to. Okay. If you do a Control C here, it will actually stop that container automatically.
No, we want to just get the difference between normally and the running with the detachment mode.
The difference is, see, normally if you are running it like this without detached mode, the logs are getting printed here only, right? But when you are running it in detached mode, if you do -d, it is running in the background. That's it. Nothing else. It's just running in the background, and you just get the ID of the container. You are not getting this details on the console directly. But if you still want to see that, you can check it in the logs. Okay. But all I'm saying is it is just running in the background. Come again?
Yes, I think it's better to run normal. Like we can see the log session, what it is doing, what happened. It will show.
Okay. Yeah. No issues. Yeah.
Yeah.
This terminal, I'll open CMD. I think get bash is stuck, man. Here it is better. Okay. Okay. Now you see these two containers are running, right? So first let's go back. I'll just stop it, right? First docker stop. I can also stop multiple together, space, right? I give like this also, it will stop both of this together. Okay, so now if I do a docker ps, nothing is actually running. Okay, so now we'll see about how to, now if you go to images, let's concentrate on one image on nginx first. Okay, so we have two different versions of the same image present. One is latest, one is 1.2. Okay, so what we'll do is how to identify which is running, right? So for example, to identify which is running, I have to give a tag called docker name. Okay, so docker run -d. Okay, if you don't want to run it in detached mode, -- name, I have to give the name called nginx 1.2. Okay, then the name of the image :1.2. So this name tag is actually trying to unable to find 1.2 locally. Okay, I missed a 0, I think. Yeah, that was the issue. Okay. It should be exactly same as the tag. Okay. So now what I have done is I have run this with a specific name. If I do a Docker PS now, let me show you here. You see, name is written as this, whatever name we gave here, right? Nginx 1.2, the same name is coming here. Okay. Similar to that, if you want to say I want to run 2 different versions, right? So I give docker run hyphen name. Let's give it as nginx new. Okay, and the image. Okay, so it is nginx. If you don't give, you can also give like this latest. If you don't give it, it will automatically take it. Okay. So now we are running. So this is running here, if you see, and also the other one is running. If I do a docker ps now, so I should see 2 different versions of the same image are running. Right. See, if you see nginx new is on nginx latest tag, and nginx 1.2 is running on nginx 1.2 tag. Okay. But the problem you see here is both are actually running on the same port on my machine. Okay, both are running on 80. So this is actually a clash, because when you run something on 80, it will not know it should connect to this image or it should connect to this image. So that is actually a problem, right? So for that case, we have another command. So let me close this. I don't know why it's not coming out. Normally when you do a control C, it should come out of the terminal. I don't know why it's not happening. Okay, I have to close it again. Nothing's happening. Okay. I have to close the terminal. Some issue with my laptop, sorry. Okay. So what I'm trying to say is both are, so we have 2 different versions of nginx running. Both are running on same port 80. This is also running on port 80, right? So that is a clash. So when you're running something, so when you give the endpoint as 80, it would not know which it should refer to this image or it should refer to this image. For that reason, we have to specify different ports for different versions. So that is one solution for that. Okay, let me stop this. For stopping also, we need to have, so instead of giving container IDs, right, we can also use the names. So I give docker stop nginx new nginx 1.2. Okay. So it is saying stopped. If I do a docker ps now, okay, so nothing is running. So what I'm saying is, so until now we have seen which we tried to give a name to this particular image. Now we'll try to change the port of this. Okay, so for example, docker. So to do that, what we have to do is same command is same, docker run, then give the name. Okay, nginx say old. Okay, nginx old, and -p. -p is specifying the port. Okay, in -p you have two arguments. Okay, two arguments you have to give. One is the local port. Okay, local port 80, any port of your local laptop versus the port on the container. Okay, and let me give this as, and the name of the image. So if you run it like this, what will happen is, so what we have done is docker run 1.2.0 I have to give. So what we are trying to do is docker run from that image here on the container. Okay, requested access is denied. I think there is some connectivity issue, sorry. Okay, so what all I'm trying to do is I'm trying to change the port, right? -p is the command to change the port of that particular container. Okay, so under port you have two attributes. One is the host port, one is the container port. -p host port : container port. Host is what in your local machine where you want that to be run, versus on the container where it needs to hit. So if you see currently it is running on Nginx is running on port 80. Similarly, Postgres would be running on port 5432. Right? Different applications run on different port, so you have to specify that port here and whichever port on your local that you want to run. Right? So those are the two things that you have to give. Try again. Let me give something called say port 1234. Any port you can give. So your laptop whichever is unused port, you can give that. Okay, there is some issue in Docker, man. Sorry. Docker PS. Let's try to figure that out. The container Nginx is already in use by container.
Kill and stop both are same, bro.
No, stop is actually just stopping that. Kill means it will, if it is unable to stop, we are forcefully stopping it.
Okay.
Yeah. So nothing is running. Okay. So let me run this again. Docker run -- name. Yeah, port, right? Okay. See, what we are doing is, so I have given this name Docker run. Okay. Name is, I have given it as Nginx new one, and port I am forwarding it to 4567 port on my local, to port 80 on the container. Okay. So if we do a Docker PS here, we can see the status where it is actually listening on. Okay, so if you see this line, right, container ID is this, name, image is Nginx, okay. Ports, if you see 0000 dot means it's your local port 4567, okay, and this is redirected to port 80 on the container, okay, and the name is Nginx new one, okay, so you can see it here. And similarly, if you want to run it, for example, if you want to run a different version of the same software on a different port, right? So let's say we are running which image it is, Nginx image, right? So we have another Nginx image 1.2, right? So let's run that also on a different port. Nginx colon 1.20, okay. I'm calling it as old one, and I'm running it on 4567. I'm running it on 4568. So the point I'm trying to make is you can have the same software, different versions running on different ports in your machine. Okay, if I do a Docker PS now, you will come. You can see that. See, if you see, there are two different images, right? One is Nginx 1.2. Other one is Nginx latest. Okay, Nginx 1.2 is running on port 4568 on our local. Nginx is running on port 4567 on our local, right? So both are two different different versions of the same application. So you can actually do that. You can actually segregate that based on the ports, right? And one more thing, so these are the basic commands, right? And one more thing, for example, like you said, you wanted to see the logs here, right? If you do detach mode, you are not able to see the logs directly on the command prompt. Okay, you can only get an ID like this, right? So other way of seeing this exact same content is there are other commands. Okay, let me show you that. For example, now we have this running, right? These two containers are running. So the command is docker container, or you can skip the container, docker logs, okay, and the name of the so the same whatever you saw here, right? The same command you can see. Similarly, new one. You can either give, so there are multiple combinations, multiple ways of getting the logs. You can either give docker container logs. You can even give, you skip the container part, you can just give docker logs. It would still work. Okay. You can give the name of the container, right? That will work. Or you can give the container ID. Okay. Instead of the name of the container, you can also give the container ID. So this is the container ID, right? So multiple ways you can actually look at the logs if you are running it on detached mode. Okay, see, even in container ID, you can see that. Even with the name, you can see that. You can give a Docker container, Docker space container space logs and give their name, or just give Docker logs. You can still see that. Okay. And for example, if you want to see what all containers you had it running earlier. Okay. So we saw the Docker PS command where we saw which containers are currently running, right? So if you want to also see the stopped, let me show you that. If you do a Docker PS, you can only see which containers are currently running, right? So currently Nginx old one, Nginx new one, these two containers are running. So if you want to see what containers are in stopped state also, then the command is -a. -a means all, right? So if you do a Docker PS -a, you can see all the containers that we ran just now. Okay. So out of this, you see the status here, up 3 minutes, up 3 minutes, up 3 minutes, up 5 minutes, these two. Okay. Other than that, whatever is below, right, these are all in, this is in created state, this is in exited state, means it is in stop state, right? This is stop, this is stop, all these are in stop state. So for example, you want to, this is in stop state and you want to turn this container on. Okay, so the command for doing that is Docker start, and for example, this particular container ID, or you can give name as well. Okay, I'll give this container ID. I give this, I run it in detached mode. Okay. So what will happen is, whatever is the stopped container also, you can actually go ahead and start it. Okay, sorry, shouldn't give that. So just give the Docker start or Docker container start and the ID or the name, anything. So this container is now started. If I do a Docker PS now, or PS-A only if I give now, so whatever the container, the ID we saw, right, 9, starting with 9 EEB, this was in exited state, it would have come in running state. So this, you see here, this has come up in running state here. Okay, up from 12 seconds. Okay, any doubts here in the commands? So let me summarize the commands, right? I'll open a notepad. Okay, I'll just summarize the commands or notepad. Okay, so the first command we saw is Docker pull and the image name. Okay, so this is actually pulling that from repo. Okay, then we saw the command to actually run that image. So Docker run image name. Okay, then we once we have that running, so to see which containers are running, you do a Docker PS. Docker PS to see running containers. Right, then Docker PS -a. Okay, this should all be in small, right? Okay, remember it's all in small. Okay, let's change it here. Docker PS -a to see running and stopped. Okay, and what else we saw? We saw Docker start and stop command. Docker start, either the name of the container or the ID of the container. Okay, similarly for Docker stop as well. Docker stop, either name or the ID, right? And in Docker
run detachment mode.
Yeah, in Docker run, right? There are many other commands we saw. Docker run, if you want to run it in detached mode, -d and the image name, right? And similarly, if you want to give it a name, right? Docker run -name, you give the name of the image. name of container, right? Name of the container, say -d, and name of image, right? Then what else we saw? You guys recall some? In Docker run, we saw the name, ports, right? Ports is important. So we saw ports, Docker run -p, right? Give the host port, host as in your laptop, right? Or I'll mention laptop port, okay? Laptop port colon your container port. Container port, how you'll know? Based on the application that you are running. So if it is Postgres, you would be running, Postgres will be running on 542.
Yeah, each application should have different port.
Correct, yeah. So the port command, right? Under Docker run, you have this command. Anything else we saw? Pull, run, ps -a, start, stop, right? And at the end, we also saw logs, right? So Docker container logs, and the name or the ID, any one of it. Or you can also do a Docker logs if you want to keep it short. Okay. Both of this would work to see the logs. And what else we saw? Yeah, one command I missed, man. So so container is what? It's actually sorry, come again.
Sir.
Yeah, thanks. So after stop, kill, we don't use it that much. If it doesn't work with the Docker stop, right? So you do a Docker kill. Yeah, forcefully trying it to stop. Yeah. Okay. So this ones and other things, right? So now if you see, I do a Docker ps. I want to get inside that container. So container is what? It's actually a machine, right, that is running. So for example, I want to log in inside that container. So there are some commands for that as well. So you do a Docker exec, okay, -it. So this command you have to remember. And the name of the container or the ID of the container, anyone would work. Okay. For example, let's go with the name of the container, okay, and which shell you want to execute it. Okay, there are certain shells, right? So these are all Linux based, right? So it will be running on bin bash or bin sh or something like that. So this is the command. Let me run it and show you once. So now if you see, it is trying to connect to this container. Okay, now if you see, the prompt has changed, right? It has become root @ something. So this is actually you are connected inside that container. See, now I'm inside that container. Okay, it is running on Linux. Okay, what else I can show you? So this is inside an Nginx container I have been. Okay, this is not my Windows machine. This is I have logged in inside the container. So what is the user share Nginx user share Nginx HTML? Okay, these files are all present inside the container. So index.html. So similarly, if you are connected to Postgres, right, you can change the environment variables. So if you do a env, so you can do anything you want, right? So these are the environment variables of this machine, right? Host name is 2092, some random things. Okay, which version? These are all the environment variables. Okay. So the command for doing that, again I'll note it down here. Okay, so Docker exec execute -it, interactive way of executing -it. Okay, and the name or ID of the container, then the shell. Okay, shell could be bin bash, bin sh. Okay, let's try. So whichever shell is present inside that container, whichever shell that image is having. Okay, image is running on, so that shell. So if I want to come out of this, I just have to do an exit. I come out of this. Let's try with some other shell, right? So bin sh. I'm not sure if sh is present. You're aware, right? There are certain shells, bash, csh, sh. Yeah, sh is also there. So now also I'm logged into that Nginx container. Okay, so it's the same container if you see, but with a different shell. So if you see the host name is same. Okay, see the file system inside, everything you can see. Okay, so yeah, so this is what Docker execc-it name or the ID and the shell. It could be bin bash, okay, or what do you call it? Bin sh or any other shell, whichever you want to connect. Okay. What other command we saw? Okay, now I have a question for you guys. Okay, so what is the difference between Docker run and Docker start? Any guesses?
Docker run will run the Docker image, but start, I'm not sure. Like I didn't have that.
No, we started, right? We did a Docker start of the name. It also started that.
Yeah, we did. But
yeah. See, the difference is, so if you're running the container for the first time, right? So then you give a Docker run. Docker run is the initial first time when you do a Docker run, it will start it for the first time. Then you can stop it and everything. From the second time onwards, you can do a Docker start, stop you can do. Initially only if you do a Docker start, it will not work, right?
Yeah, first we need to run it, after that only we can start.
Actually, this Docker run command is a combination of Docker pull and Docker start. So actually, if I tell you the theory, right, Docker run is equal to Docker pull plus Docker start together. So I can I need not pull the image and do a Docker run. For example, let's take some other basic image. Okay, where is Docker? Take some image. Okay, let's take Redis, right? Okay, so I need not do this. I can just directly run. I'm coming out of the container. Okay, I can directly run Docker run Redis. Okay, and I can give the ports and everything. Okay, so what it will do is it will try to find this. If you see the flow here, right? Where is this? So I'm directly doing a Docker run. It will come here. It will try to find it inside my host. If the image is present, it is not. It will try to search here. It will download it. Download the image, run the container. Everything it will do, right? So if it is saying, see, unable to find locally. So it is trying to download that. I didn't do a Docker pull. I just did a Docker run. Okay. So it downloaded it. It ran it also. If you see. So if I now go to some other terminal, this is the plain one. So if I do a Docker PS, you can see that. So if you see from the logs also, it is clearly visible. So unable to find. So it went up, it downloaded that image, then it downloaded newer image, then it also started that image, right? And it is ready to accept connections. It is running as well, right? Let's see here. Yeah, you see here it is in running state. Okay. So what I was trying to say is Docker run will actually do a Docker pull and Docker start together. Got it? Yes. See, one more thing, right? You guys were saying about Postgres. Let's try that quickly. Okay, I have an image. For Postgres, we downloaded an image, right? So let's try to run that, and we can actually see the steps to run it here also, right? You see, if you are new, right? If you don't want to, like, if you are not aware, so you can actually come down here. You can see the commands. See here, the same commands whatever we gave, right? Docker run -it -rm means it's removing it. So this is little complex. It is giving the network, right? And the host name, the username, password. So there are multiple um, uh, parameters that you can pass. Okay. See, my secret password. So while running that, so what I'm trying to find in that is I need to pass the username and password, right? So that's what I'm trying to see where to pass that. Okay, so plain. Let's run it plain. This one, I think we have to give this. Okay, let's try that. Anyways, okay, we have a Postgres image now. Okay, I'll do a Docker run. Okay, I'll run it in detach mode. We'll see the logs separately. Okay, -d and -p. So which port I want to run it on? Okay, let's say I run it on 3333 on my local, and Postgres, as you know, it will run on 5432. Okay, on the container, and here I need to specify an environment variable called Postgres password. If you see, these are the environment variables. If you see, come here, environment variables, there is an environment variable called Postgres password. Okay, so -e, I have to give this environment variable. Okay, how do you give that? Equal to, say, p Postgres at 123. Okay, and what else I need to give? So I think it will take it as a default. This is optional. So there are some mandatory, there are some optional. Okay. So if you see Postgres password, the environment is required for use to Postgres. Default is Postgres user. The optional environment variable user is. Let's give that also. Yes. -e Postgres user equal to, let's say it as Postgres. Okay. And that's it. This is just the environment variable that I'm adding, right? And at the end, I have to give what name of, let's give name also, right? -name. Let's call it as PG Docker. And at the end, you have to give the image. You can also give latest. If you don't give, it will automatically take. Okay, let's try this. I think you have to give it separately or together. So now, so if I do a Docker PS, now this container is running, this Postgres container, okay, with the name pg-docker. You see here, first one, right? It's running, and it's running on local port 3333. Okay. So now let me see the logs of this. So what is the command to check the logs? Docker logs and this, right? See, this is the logs for that Docker image here. The files belonging to something came, right? Some bootstraps. So whatever the binaries and all it needs to download and run, everything is happening. At the end, if you see, database system is ready to accept connections is what it's saying, right? So now if you actually, you can actually try connecting. Okay, I have PG admin in my local. Also, we can also connect to that. We can get inside that, right? We know the command for that. Getting inside that container, exec-it, and the name of our container, which is this. And let's say I go to bin bash. Okay, now I'm inside this. If you search the environment variables here, see Postgres password, whichever we gave, right? Postgres has 123, that is there. And this is where the data directory inside the container, where lib Postgres SQL data, right? These are database related, right? So let's try that. Okay, server, create server, okay, Docker EG, then connections, I have to give 127.0.0.1, right? Port is what? Port is not 5432, right? We have changed the port. What port did we give? 3333, right? This is on our laptop. 3333. I think this is same username. I think we didn't give anything. Password we gave it as Postgres at 123. Yeah. Let's try to connect. Yeah, it is connected. If you see here, right? I'm connected to that. Right? Nothing here. We can actually, we are actually connected to this database. So this doesn't have anything. I think it will be empty. Okay, this is how you can actually, if I just stop it now, right? So this is, if I just go to the terminal again, right? Okay, I'm inside the container here. If you see this command, this got changed, right? The terminal. So I can come out of it using exit. Now I say I do a Docker stop, and what was the name? PG Docker. Okay. So I have stopped this now. Okay, now the container is stopped. Let's verify. Okay, now it's not running, right? Postgres is not running. So now I think the if I just refresh, the connectivity should actually go. Or yeah, would you like to reconnect? Yeah, you're getting my point, right? I think it will take some time. Disconnect server, okay, and connect to server. How is it? Yeah, so it's asking for the password. What was the password? Postgres at 123. Right? It will not connect. Could not connect to server. Connection refused. Right. So if I just turn it on quickly. Okay, now it's running. And now let's try that. Postgres at 123. Yeah, you see now it's connected. So you're getting my point, right? So we can actually do it very easily. So all you have to do is you can also control it from here, right? If you see now, either through command line is always better, but Windows desktop, Windows Docker also gives this UI where you can stop and start containers from here as well. Where is that RPG Docker, right? I can stop it from here. I can start it from here. It will do in the backend, it will just run that same command. Docker start, Docker stop, all that. Right? You can also see the logs and all from here. So this is only specific to Windows. It has this additional user interface. So if you see, it is trying to get inside that the same command which we gave, right? Docker execc-it, the container ID bin sh. So you can also, so it's better to remember the commands, right? But you also have a graphical this user interface where you can use. Okay, I think that's it I had for today. So tomorrow we'll try to, whatever the Docker commands we gave, right? We'll try to put it inside a Docker file and a Docker compose file and try to create that. So that is the next step.
Yeah.
Right?
Like, are we going to create a Docker with Docker container for a specific application, like putting inside the different images?
I didn't get you. Can you repeat once?
Yeah. Are we going to create a container with the different images, like for application? Any application?
Yeah, we can take one sample application, right? And we'll try to build a Docker file for that. So for example, you have some Node.js or a Python application. So how you actually, Python application we can take, and we'll try to build a Docker file, try to run that application through Docker, right? So we'll try that using Docker file tomorrow, right? That's it. Just last slide I forgot. So this container port versus host port we already discussed, right? So this is running on the host, whichever port. Now we give 3333 on the host on your laptop. So that we have to map it to which is running on the container. Yeah. See, there are two parameters to that. After -p, you see there is laptop port, your host port, and the container port. So for each application, the container port is different. For Postgres, it is 5432. For Nginx, it is 80. For Mongo, it is 27017. So based on the containers port, you have to give that. And which port you have to map it on your local. Any unused port of your local machine, you have to give in the first one. Okay, guys. Any other doubts? Okay, we'll see Docker images, right? Docker file, Docker compose in the next session. So please try to attend the next one. Right? This will be a continuation. Okay, thanks guys for your time. It was a good session. Interactive. Let's keep this interactive, right? It was good this time. Okay, thank you. Thanks for your time. Bye bye.